Quantum computing is a revolutionary technology that enables the exponentially faster computation of a specific set of problems. Contrary to common misconceptions, quantum computers will not replace all conventional computers, but rather be deployed alongside them to solve specific tasks far more efficiently, in a somewhat similar manner to existing accelerators or GPUs. Currently, there are 8 different tech approaches which are leading in the race to build a commercial quantum computer. This variety not only breeds competition, but there are also different materials and infrastructure requirements between these different technology approaches. You can broadly categorize these 8 approaches into 4 more commercialized technologies, which for a few years now have been shipping products. These are the superconducting, trapped ion, neutral atom, and photonic approaches. And then there are also 4 more alternative approaches, the silicon spin, topological, diamond defect, and annealing platforms, which are mostly at an earlier development stage currently, but each hold a set of advantages that could see them leapfrog the mainstream competition in the long term. The primary long-term business model for quantum computers is comparable to that of existing supercomputers. Hardware providers will make their technology accessible via the cloud, and both the hardware and cloud service provider will collect a percentage of the usage fee. This is known as Quantum as a Service, or QaaS, and is available today either directly through quantum computing companies or through platforms such as Microsoft Azure Quantum or Amazon Braket, which connect end users with quantum hardware that is hosted by a range of suppliers. While the quantum hardware accessible today is still early stage and not yet outperforming classical computers on commercial problems, it is still available for the purpose of allowing users to develop use cases in anticipation of more advanced hardware, as well as being used for educational or research tools. The motivation, therefore, for quantum computing to move into data centers is to grow this business model by hosting quantum computers in an environment that is already specialized for cloud connectivity. The quantum computing industry is now an inflection point, where within the next few years, the technology must demonstrate scalability, realize use cases, and secure early adopters to return value on the billions of US dollars that have already been invested. In recent years in particular, the development roadmaps of startups have accelerated, with several market leaders now predicting that commercially relevant quantum computing may arrive before 2030. For more information on the quantum computing market and related timelines and forecasts, please see the ID TechX Quantum Computing Market Research Report.